Hello friends, welcome once again to my channel. Today we are going to discuss the solutions to differential equation through separation of variables. If this is your first time of viewing, kindly consider subscribing to my channel so that you'll be notified whenever I upload a new content. Okay, now you can employ the usage of separation of variable other than the direct integration method of solving differential equation, which I taught you in my last video. You employ this method if you have a function like dy over dx equals f of x comma y. That is when it is somehow implicit differentiation. That is when you employ this particular method. Okay, now look at the question we are given here. We are asked to solve this given differential equation, and the first one says that dy over dx is equal to 2x over 2 over y plus 1. To solve it by separation of variable, it implies you can move y to the left hand side while x stays to the right hand side, so that they will be separated. X variable stays together while y variable stay together. So here, to move this y to the left hand side, I can choose to multiply both sides by y plus 1, so that y plus 1 will cancel out. And remember, in equation, whatever you do to both sides makes it balanced. So multiplying both sides by y plus 1, I'll have y plus 1 multiplying dy over dx equals 2x over y plus 1 being multiplied by y plus 1, so that y plus 1 cancels out. We are left with y plus 1 dy over dx equals 2x, because y plus 1 has cancelled y plus 1. Now, at this point, I can choose to integrate both sides with respect to x, so that we can get something useful. So now, if I integrate both sides with respect to x, I'll have y plus 1, the integral of y plus 1 dy over dx. With respect to x, I'll put the x because I'm integrating with respect to x, equals integral of 2x dx with respect to x, so that the x cancels the x. I will now have integral of y plus 1 dy. I'm left with dy here, equals integral of 2x dx. You can now see that at this point we have separated the variables very well. We are now integrating y with respect to y, and we are now integrating x with respect to x. So from here, if we integrate y, remember the rule of integration. The power here is just like 1, the power here is just like 1, even though you can't see them. So to integrate y, I will now have it as y power of 1 plus 1 all over 1 plus 1. If I integrate any constant with respect to a given letter, it gives me that letter. So when I integrate 1, I will get y equals 2x. If I integrate it, I have 2 power of x, 1 plus 1 over 1 plus 1, then plus the constant of integration. So at the end of the day, I'll have 1 plus 1 is 2, y squared all over 2 plus y equals 2x squared over 2 plus c. Now these two can cancel out. Finally, we shall have y squared all over 2 plus y equals x squared plus c as the solution to this given differential equation. So let us clean the board and take the second one. In the second question, we have dy over dx equals 1 plus x into 1 plus y. Now I need to move y to the right hand side, and to move y to the right hand side, I've got to divide both sides by 1 over 1 plus y, or I multiply both sides by 1 over 1 plus y. So I will have 1 over 1 plus y multiplying dy over dx equals 1 plus x into 1 plus y multiplying 1 over 1 plus y. Okay, or rather, you can claim this 1 over 1 plus y. Okay, so from here, this will cancel this. We are left with just 1 over 1 plus y dy over dx equals 1 plus x. Now I'll integrate both sides with respect to x. So I have integral of 1 over 1 plus y dy over dx equals integral of 1 plus x dx. So that the x cancels out, we are left with integral of 1 over 1 plus y dy equals integral of 1 plus x dx. Okay, so the variables has been carefully separated. We have y here, we have x here. And when you are differentiating 1 over any number like this, 1 over any number, the integral, not even differentiation, when you integrate a function like this, it gives you the natural logarithm of it. So this is the same thing as giving us, when I integrate this, I will just get logarithm of 1 plus y equals, the same thing applies here. This is x, 1 plus x. If I integrate 1, I will get x plus, if I integrate x, I'll have x 1 plus 1 over 1 plus 1, then plus the constant of integration. Okay, so we still have ln 1 plus y equals x plus, this is now x squared all over 2 plus c. Okay, so this can be the integral of this or the solution to this given differential equation. Ln 1 plus y equals x plus x squared all over 2 plus c. So I will clean this to take the last question. So have dy over dx equals 1 plus y over 2 plus x. That's the last question we'll have here. So to separate the variables, I need to move this 1 plus y to the left hand side. And how do I do that? I need to divide both sides by 1 plus y, or multiply both sides by 1 over 1 plus y, so that 1 plus y will leave this side. So I will now have 1 over 1 plus y dy over dx equals 1 plus y over 2 plus x multiplied by 1 over 1 plus y. So that this will cancel out. We are left with 1 over 1 plus y dy over dx equals, this is now 1 over 2 plus x. That is what we are left with. Now I can choose to integrate both sides with respect to x. I will now have the integral of 1 over 1 plus y dy over dx, because I'm integrating with respect to x, equals integral of 1 over 2 plus x dx. So that this dx, they cancel this dx. We are now left with integral of 1 over 1 plus y dy equals integral of 1 over 2 plus x dx. Okay, now if I integrate this will give me ln 1 plus y equals, if I integrate this, it will give me ln 2 plus x, then plus c. If I like, I can stop here, but if I want to make it more mature, because in the previous two questions we solved, there is no presence of two logarithms like we're having here. So in the previous question, we just have logarithm just in one place. But since it is up to two places, let us change this letter c to maybe a given letter a, because a constant is a constant, arbitrary constant. C can be a constant, a can be a constant, it can be anything. So if I choose to change this c to a, I'll have ln 1 plus y equals ln 2 plus x plus let's say ln a. Okay, because a constant is a constant. Now this finally gives us ln 1 plus y is equal to, in the laws of logarithm, whenever you are adding, you multiply. So we shall have it as ln a multiplying 2 plus x, because 2 plus x is multiplying a. We have ln a into 2 plus x. And logarithm is common here. You can cancel out, giving you 1 plus y equals 2 plus x. Then this is just 2 plus x bracket a. The a can come first or it can come last. So this is just the solution to this given differential equation. If you've enjoyed what you've watched, kindly consider subscribing to my channel so that you'll be notified whenever I upload a new content. Thank you.